Alright, welcome to lesson 1.3. So we're going to investigate a relationship between slope and rate. Okay, so let's check out the first part here. So Robin is preparing to make taquitos for supper. Not very healthy, Robin. She preheats the oven to 400 degrees Fahrenheit. The graph shown represents the temperature of an oven as it warms up. What does the point 0, 50 on the graph represent? So that 0, 50 is right there. What does that represent? And it represents the resting temperature. So if you think your oven isn't going to be 0 degrees Fahrenheit because that's freezing, it has to have some temperature because it's in room temperature. So it represents the room temperature. All right, part B. What does the point 5, 400 on the graph represent? Well, 5 corresponds to the time in minutes, and 400 corresponds to the oven temperature. So that represents that the oven is 400 degrees after 5 minutes. Let's try a different color font here. Calculate the slope of the line joining these points. So slope is rise over run. So let's check out the rise here. So it rose how much? Well, it was at 50 degrees and it went to 400. So the rise, it rose 350 degrees. Let's check out the run. It went from 0 minutes to 5 minutes. So it's 5 minutes. Okay, the slope represents a rate of change in temperature divided by a change in time. What units are used to represent this rate of change? Well, it's going to be degrees per minute. Okay, so degrees per minute. All right, let's check out the next one. Complete the statement. The temperature is increasing because it's going up at a rate of, well, if you divide 350 by 5, you get 70 degrees per minute. That's your rate of change. Part 2. Water is leaking out of the bottom of a barrel at a constant rate. So constant means it doesn't fluctuate, it's the same. After 2 minutes, the water level is 62 centimeters, and after 7 minutes, the water level is 22 centimeters. On the grid, plot ordered pairs of time and water level to represent this information. So normally in a graph, you put time on the x-axis. So time goes from 2 minutes to 7 minutes. So we're going to have about 1, 2, 4, 5, 6, 7. We'll do 8 minutes there. 2, 4. Okay, hopefully you can read that. And then we need to do the water level. So it needs to go up to at least 60. So let's go 20, 40, 60, 80. Okay, it's pretty rough. The first point is going to be at 2 minutes. It's about 62. So let's see if I can put a dot there, okay? And then after 7 minutes, it's down to 22. Okay. Now that we have 2 dots, you can join and create a slope. Alright, so calculate the slope of the line segment. So the slope is going to be the rise. Well, we're not really rising, we're going down. How much did it go down? 62 to 22. It went down about minus 40. So now you can calculate that down, get in your lowest terms. So if we divide each term by 5, we should get -8 centimeters per 1 minute. Okay? Slope represents a rate of change, a change in water level divided by a change in time. What units are used to represent this rate of change? Again, this is centimeters per minute. Complete the following to explain what the rate of change in this scenario represents. The water level is changing at a rate of, well, you can say -8 centimeters per minute, because it's going down -8. When you're talking about just levels, you can say the water level is decreasing at a rate of 8 centimeters per minute, because decreasing tells you that it's going down. All right. If we're just talking about changing, we need to include the sign. It's going -8 centimeters per minute. It tells us it's going down. If we're just saying increasing or decreasing, then we don't need the negative sign. All right. In the previous investigation, we talked about that slope represents a rate of change. So rate of change can be used to describe many scenarios. For example, change in distance traveled to change in time, change in temperature to change in time, change in salary to change in sales, etc. A positive slope indicates a positive rate of change. Okay. A negative slope indicates a negative rate of change. So if you're thinking about the stock markets, going up is good, going down is bad. Okay? Positive, negative. On a graph of distance as a function of time, the slope of a line segment joining 2 points represents the average speed between 2 points, as illustrated in the class example below. Dave entered his car in a long-distance car race. He traveled the first 150 kilometers in 2 hours. After 6 hours, he traveled 650 kilometers. So plot the ordered pairs to represent this information. So let's do that. So the first thing we need to do is put in 0, 0 is our first point. Why do we need to include 0, 0? Well, if he's in a race, he's starting at the start line. So we need to have at least 6 hours. So let's go 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6 hours, and we'll get a 7th hour in there. And distance traveled, we need at least 650, so let's go 100, 200, 300, 400, 500, 600, 700 is going to be up there. Okay, so we need to plot this point here, so 2 hours, and what did I say, 100, that's 200, so 2 hours, this is your time. 2 hours goes 150, and 6 hours goes 650. So 6 hours, 650. You can label these points too. So this is going to be 2, 150, and this is going to be 6, 650. Okay, and once they're all there, you can connect the first two, and then you can connect the second two. Okay. Calculate Dave's average speed between 2 hours and 6 hours. So again, we're going to go rise over run. So look at the graph. The rise from 2 hours to 6 hours. Well, we went from 150 to 650. So what was our rise? It was 500 kilometers. And what was our run? Well, we went from 2 hours to 6 hours. So it's 4 hours. And you can reduce that to 125 kilometers per hour. By looking at the grid and without doing any calculations, how can we tell that the average speed during the first 2 hours was less than the average speed during the next 4 hours. So look at the graph and maybe try and figure out why. You can just look at it and tell. Well, if you look at the slopes, the slope for the first 2 hours is not as steep as it is for the last 2 hours. So there's a slope for the first 2 hours, and then it goes up a little bit steeper for the next ones. So the answer here is the slope is not as steep. Okay. The graph shown represents the amount of fuel in Dave's gas tank as a function of distance traveled during a portion of the race where he drove at a constant speed. Calculate the slope of the line. So again, the slope of a line, rise, overrun. Let's calculate the rise. So we're going from here to there. So we're looking at the y values, 50 to 40. So we went down -10. And our run, we went from 20 to 120. So our run is 100. And we can reduce that to -1/10. And what are my units? Well, the y value is liters, and the x values is distance in kilometers. So for every liter burned, they traveled 10 kilometers. Or Dave traveled 10 kilometers. So complete the following statements. The amount of fuel is decreasing. The rate of change of fuel in the fuel tank is -1 liter per 10 kilometers. The amount of fuel in the fuel tank is decreasing. That's, remember, the key is decreasing at a rate of 1 liter per 10 kilometers.